Good morning students. Previous class we have learned about Newton's laws of motion and law of conservation of linear momentum. First of all, we can revise Newton's first law. Every body continues to be state of rest or of the state of uniform motion along a straight line unless it is acted upon by some external force. Newton's first law is otherwise known as law of inertia. Next one, Newton's second law. The force acting on a body is directly proportional to the rate of change of linear momentum of the body, and the change in momentum takes place in the direction of force. So the Newton's second law is otherwise known as law of force. Newton's third law. For every action there is equivalent opposite reaction. They always act on two different bodies. Next one is law of conservation of linear momentum. First we can revise the definition. There is no change in the linear momentum of a system of bodies as long as no net external force acts on them. Next we have learned about the derivations of the linear momentum, and the final we have learned this: the sum of the momentum after collision is equal to the sum of the momentum in before collision. Did you learn, students, derivation? Very important question. Next one is impulse. A large force acting for a very short interval of time is called an impulsive force. When a force F acts on the body for a period of time t, then the product of force and time is known as impulse. Impulse denote the letter J. What is the formula for impulse? J equal to F into T. What is the unit of impulse? Is kilogram meter per second or Newton second. Today we can learn about rocket propulsion. Liquid rocket engines are one of the most difficult and complex in machinery made by the mankind. The first working by the rocket engine, an American scientist, Dr. Robert King, in 1926. The rocket consists of two things. One is oxidizer tank and the other one is a fuel tank. The fuel and oxidizer are separately stored in two tanks in the form of liquid. The combination of fuel, the oxidizer, are called propellant. In liquid propellant, the rockets, the fuel oxidizer, are in the form of liquid. So, these rockets are called liquid propellant rockets. The couple of turbo pumps to pumping oxidizer fuel to the combustion chamber. Combustion chamber, the fuel and oxidizer makes to burning inside the combustion chamber. Next one is fuel injector. It can burn liquid fuel and oxidizer mixture into small droplets and spray inside the combustion chamber. Ignites with the help of electrical signal. It generates spark and burn the propellant. This is the nozzle. It is used for expanding and accelerate the combustion gas. Next one is working principle of the rocket. With the help of the turbo pumps, the fuel and oxidizer pumped into the injector. The injector converts the liquid into propellant into small droplets and spray into the combustion chamber. The flow of the injector controllable if it's increased. Decrease the flow of propellant with the help of the electrical signal. The infrared generates spark. Due to the ignition, the combustion takes place. When the combustion takes place in the combustion chamber, very high pressure and temperature gas produced. In the nozzle pressure, energy of gases to get energy. So, these gases are formatting with high velocity. It produces an opposite direction. The thrust propellant of rocket move forward. Clear idea about rocket propulsion. Here you can see the outline of the rocket. Look at this picture. Get two tanks are there. One is the fuel tank, another one is the oxidizer tank. What are the two tanks? Fuel tank and another one is the oxidizer tank. Now here see two pumps are there, turbo pumps. Two pumps, turbo pumps. In the fuel tank, the liquid, whether it is liquid or soil, fuel is there in the fuel tank. Here oxidizer are there, and through this the turbo pumps, both the fuel and oxidizer will come through this injector through a droplet. Okay, after that it will come in the combustion chamber. So in this combustion chamber only combustion takes place with a high pressure and temperature. Through the nozzle the hot gas will be ejected. Okay, this is the principle used in rocket propulsion. Now we can see what are the principles used in rocket propulsion. The first principle is law of conservation of linear momentum. First principle, law of conservation of linear momentum. Second principle, Newton. Third law of motion. So what are the principles used in rocket propulsion? Law of conservation of linear momentum and Newton's third law of motion. Okay. What are the principles used in rocket propulsion? Law of conservation of linear momentum and Newton's third law of motion. Now look at this picture. It has two tanks already I told. No? So first the rockets are filled with fuel. Okay. So first we can write here fuel. So the rockets are filled with the propellant tank. The rockets or the fuel is filled with the propellant tank. Then when the rocket is fired, the fuel is burnt and the hot gas is ejected. Okay, here has some huge momentum. So next point, hot gas is ejected. So first you have tried the principle. Next, the rockets are filled with the fuel in a propellant tank. When the rocket is fired, the fuel is burnt. The hot gas is ejected through nozzle. This is the nozzle. Okay, through the nozzle, the hot gas is ejected. And here some huge momentum takes place. Momentum means what? Momentum. Already you have learned, no? Momentum. Momentum means linear momentum you have learned. What are there? Mass and velocity. No, mass and velocity only momentum. This all of you know. So here mass also there, velocity also there. Okay. So first fuel, next hot gas ejected, next momentum takes place. Now here action and reaction takes place. So what and all? Action and reaction takes place. So action and reaction means which principle used here? Newton's third law principle. No. So Newton's third law means what? for every action there is equal and opposite reaction. Now we can see here action and reaction. So action means what? Hot gas is ejected. We have learned now. How much hot air is ejected, that much force the rocket to move forward. Okay. So here the hot gas is ejected. Here action happens and here reaction there. So action and reaction takes place. So which principle used? Newton third law of motion. Now first you have to write the principle. Two principles you have used: law of conservation and linear momentum, Newton third law of motion. So now we have learned how the third law applied here. Okay. So first the fuel is, the rockets are filled with the fuel in a propellant tank. Then what happened? The rocket is fired, hot gas is ejected, and there is some huge momentum of that. Momentum there means what and all there? Mass and velocity. So here action and reaction takes place. How much the hot air is ejected, that much the rocket to move forward. Okay, here action and reaction. Now the next one, next principle how it used, we can see. While in motion, the mass of the rocket, here the mass of the rocket decreases. Which one will increase? Velocity will increase. Okay. The mass of the rocket decreases. The fuel is completely, until the fuel is completely burnt. The mass of the rocket decreases with the altitude. So here momentum there means what and all there? Mass and velocity is there now. So the mass of the rocket decreases. Mass decreases. Which one will increase? The velocity increase. Increase with the altitude. Okay. The mass of the rocket decreases. Which one will increase? The velocity of the rocket increases with the altitude. Here, which law used here? Law of conservation of linear momentum. What's the law of conservation of linear momentum? Without applying any external force, the total momentum before collision is equal to the total momentum after collision. This we have learned, last class we have learned. No? So here we are not giving any external force. Okay, we are not giving any external force. The mass decreases with altitude and the velocity of the rocket increases. In one stage, it reaches the velocity. It escaped just the gravitational pull of the earth. That means 300 km above. When the rocket reaches, there is no gravitation. No. So it escaped the gravitational pull of the earth. This velocity is called escape velocity. So these are the rocket propulsion. Important question. The question is describe rocket propulsion. So very easy question. Just you know the concept and you have some idea about rocket propulsion, and like this take notes and learn. Very easy for you. Okay. Once again I am explaining. First, here used what are the principles used in rocket propulsion? Say students, what are the principles used in rocket propulsion? Law of conservation of linear momentum, Newton third law of motion. So 2 mark question or 1 word question it comes, you have to write law of conservation of linear momentum and Newton third law of motion. Okay. So next one, the rockets are filled with fuel. Fuel means whether liquid, here liquid fuel written, liquid or solid. Okay. So the rocket are filled with fuel in a propellant tank. What happened? The rocket is fired, the fuel is burnt and a hot gas is ejected through a nozzle of the rocket propulsion. What happened? A huge momentum produced. So momentum means what and all there? Mass and velocity is there. So here action and reaction takes place, and the action one side, opposite side only reaction will takes place. So when the hot gas is, how much hot gas is ejected, that much the rocket move forward. Okay. Then while in motion, what happens? The mass of the rocket decreases with altitude. What happens? The velocity of the rocket increases. In one stage, it reaches a velocity just escape the gravitational pull of the earth is called Which velocity? Escape velocity. This much you have to write. This 4-mark question. Question is describe rocket propulsion. Listen here. Solved problem. Rome letter 7. Question number 1. Okay, I am reading the question. Just listen. Two bodies have a mass ratio of 3:4. So the mass ratio of first body is 3 kg. Mass unit kilogram. 3 kg. The mass ratio of second body is 4 kg. Like that you have to write. Next, the force applied on the bigger mass acceleration of 12 meters second power minus 2. So bigger mass acceleration. Acceleration denote the letter A. No. So bigger mass acceleration you have to take as A2. And smaller mass acceleration you have to take A1. So what you have to find? What could be the acceleration of the other body? A1 only you have to find out. So one condition is given if the same force act on it. This is the condition. Here force is same. Okay. So we have to find A1 you have to find out. Now we can do this problem. All of you listen. First solution. First we can write mass ratio of two bodies. Here given mass ratio of two bodies. It's a 3:4. No. So the mass of smaller body. Mass of smaller body. You can write this as M1 equal to 3 kg. The mass unit is kilogram. The next one, the mass of bigger body. That is M2. It's at 4 kg. Here this question given, ratio given. So we have to write here mass of smaller body M1 equal to 3 kg. Mass of bigger body M2 equal to 4 kg. Okay. So next what is given? Acceleration is given. No. So we have to write acceleration due to force applied by bigger body. That is A2 equal to acceleration denote the letter A. Here bigger body na, so A2. Smaller body means we can write to A1 equal to what is given here? 12 meters second power minus 2. How you know acceleration is given? By using this unit. Okay, meter second power minus 2, the unit of acceleration. What you have to find? A1 only you have to find out. The acceleration due to force applied smaller body, A1 only you have to find out. So you have to find A1, you have to find. Now, according to first what is given, you have to return. No? Then we apply formula. So according to Newton's second law, Newton's second law of motion. What is the formula? F equal to ma. You have learned this derivation also. No? F equal to ma. This common formula for us here mass m1, m2 and a1, a2 there. No? So we can take this F equal to m1, a1. Why here f1 no need to write? Because the same force. No, force same. So no need to write to f1. So just we can substitute the value. What's the value of m1? 3. a1 we don't know. So we have to write here a1. So F equal to 3a1. This equation number 1. The next F equal to m2, a2. So what's the value of m2? 4 into what's the value of a2? 12. So just to multiply 12 into 4. So here 8, 48. So you'll get here 48. So F equal to 48. This equation number 2. Then equate equation number 1 and 2. Equate equation 1 and 2. See here F, here also F. No, so this we can cancel. So you will get 3a1 equal to 48. Can you understand, students? From here you have to find A1 equal to 48 divided by 3. Just divide means you will get the answer. A1 equal to 16 answer. What is the unit of acceleration? Meter second power minus 2. So here given now question, what could be the acceleration of the other body? So the what's answer? 16 meter second power minus 2. So right, last answer. So acceleration due to the same force on the smaller body A1 equal to 16 meter second power minus 2. Okay. Today's worksheet for you. First question, describe rocket propulsion. Page number 8. This question for you, book back, Rome letter 8, question number 5. Okay, describe rocket propulsion. Page number 8. I am reading, just listen. Propulsion of rockets is based on the law of conservation of linear momentum as well as Newton's third law of motion. Rockets are filled with a fuel in the propellant tank. When the rocket is fired, this fuel is burnt and a hot gas is ejected with a high speed from the nozzle of the rocket, producing a huge momentum. To balance this momentum, an equal and opposite reaction force is produced in the combustion chamber, which makes rocket project forward. While in motion, the mass of the rocket gradually decreases until the fuel is completely burnt out. Since there is no external force acting on it, the linear momentum of the system is conserved. The mass of the rocket decreases with altitude, which results in the gradual increases in velocity of the rocket. At one stage, it reaches a velocity which is sufficient to just escape from the gravitational pull of the earth. This velocity is called escape velocity. 4 mark question, very important question, learn well, students.